All right, welcome back. We are game 3004 in the winter 2021 semester, and it is week 4, part 2 of our broadcast. And we're talking about shaders and materials and texturing and lighting and what all those things are. I kind of included a couple of slides here inside of your of your document. One thing is that you're going to be make extensive use of meshes, materials, shaders, and textures in Unity because we're doing things in 3D this semester. So again, I kind of put in just an excerpt from Unity's documentation, the latest version, around what meshes are, what materials are, and so on. And I think you know about this already because you have done OpenGL as an example before this in another course. So this course builds on that knowledge. So if, things that we've talked about, let's say with C++ and OpenGL, you're going to take advantage of the Unity's game engine and work kind of through the process with Unity, which is much easier than making it work in OpenGL on your own. So again, what material does, as a reminder, is it specifies one shader to use, right? And that shader really determines all the properties that are available in the material. So as soon as you attach a shader to a material or you select a shader, whether it's something that's custom or something that you have selected. Sorry, Russ, you're unmuted. I'll mute you there. So depending on which one you select, then you have different capabilities, different properties that are exposed, as an example, in the interface. Okay. Materials, on the other hand, once you select a material, so here's an example of standard material, and we'll be talking today about other types of materials in Blender and how they match or map one-to-one with the materials here in Unity. And for example, here in Unity in the standard material, we have albedo, or albedo, depending on how you want to pronounce that, normal maps, height maps, occlusion, emissions, detail masks, and so on. And what you can do is you can connect or drag and drop from the textures that you're loading, the texture files, into these little slots to basically make your object appear how you want it to appear. In this case, it's a roof tile, but that's how it works. So what does this look like in Blender? So Blender materials are something we have to talk about. They're data blocks. And it's different than maybe in other programs. And what you can do is you can assign these data blocks to different objects or different parts of an object even, different meshes. And really what we do is we use image textures. There's two ways it can be done. You can do it procedurally through some kind of noise. And Russell was talking about noise in terms of procedurally generating his world, but you can actually do procedural generation of textures. Blender can do it, but there are some great tools out there to do it as well. And one of them is Substance Designer. So if you actually look up Substance Designer, I would say this has kind of become the de facto standard now when it comes to procedurally generating textures. And it's pretty awesome because what it allows you to do is it uses a node-based system, very similar to what we use in Blender, as well as what we can use in Unity, right? So in Unity, what we do is we have something called shader graph that we'll be exploring later this semester, and so you can create your own custom shaders. Here, what you're doing is you're creating custom textures. So you create a texture, and what you can do is this texture is procedurally generated or created with a series of nodes, and then you can output this substance, this texture, out to Unity, right, or to Blender. You can actually use this thing, which is pretty cool. So Substance again has become, pretty awesome in terms of what you can create instead of you going out there and getting samples of actual materials out there. You can really be creative in how your materials map to your objects, and you can create them. There's a whole other, I would say, job just in terms of you creating textures and using Substance. Substance, by the way, is now owned by Adobe. It used to be kind of its own company, but Adobe's acquired it, which is a great move for Adobe, as it's pretty awesome. Okay, so that's Substance Designer. But Blender can do a lot of this as well, maybe not in so much detail, but it can definitely do quite a bit of it, kind of right free. And you can do a lot of, creating your own material effects and so on right in Blender. One thing that we're going to notice in Blender is that there are 3 little piece parts to a material. One of them is surface, another one is a volume, and the third is a displacement. And remember that what a surface is, it only affects the surface normals and the surface itself. Volume actually changes the way a volume works. Sometimes we want to make use of volumetric shading, right? So inside the volume itself, things like caustic shaders that would work inside of water, as an example, where you're inside water and you see kind of like, this refraction effect, or even as much as volumetric lighting. Then there's displacement, where you actually apply a shader so it physically displaces the geometry of an object. So these are all possibilities with the material. And it talks about that here. This is your reference that I pulled together for you. One way that we do it in Blender that you're going to see today, and we talked about that last week, is this material slot. So the material slot is, like we said, it can be added to any mesh, right? And once the material slot, one or more material slots are added to the mesh, you can add one or more textures, whether they're a single texture or multiple textures that are layered together to create an effect, as an example, on parts of your object. Okay, so that's one way that it works. One thing that we also talk about is a surface shader, which defines really the light interaction on the surface of a mesh. And remember that when we talk about light in 3D, there's no light, right? It's really, we're coloring the pixels on a 2D screen. So to make it look like it's 3D, we're projecting 2D to 3D to 2D, so we can actually work with objects that appear to be 3D in our environment. And we're doing some complicated math to make that done. Some terminology we're going to run into today when we do our lab is BSDF. We're going to see that, which is bidirectional scattering distribution function, which really defines this the type of shader that we're going to be using. So a BSDF material allows different properties to be added, much more perhaps than regular materials. We know what reflection is. Reflection is when you have an incoming ray and where it goes on a surface. Transmission, how the incoming ray on the surface leaves on the other side. And refraction, how rays kind of hit a surface and then they scatter, right? Which is whether it's through subsurface scattering or when they bend as they come out. Think about a glass of water and how light, if you put some kind of spoon in a glass of water, when you see something in a glass of water, it seems to be a little bit off. It seems to be affected. It's not completely transparent. There's, you can see a spoon that seems to bend. That's because the light that's going through the glass, which is going through water, there's an index of refraction for water, if you remember from Physics 101, and then it shifts the light or bounces the light, so it appears that the spoon is bent, but actually it's not. Right, so that's kind of what refraction does. And then when it comes to volumes, things like when we want to create things like fire and smoke and clouds and any kind of volumetric effect, that's where volume comes into play. And here's an example of a principled volume. And a principled volume is a very realistic, physically based, kind of aspect of shading. So when we say a principled BSDF, right, then we're seeing that it's physically based, a physical based shader that we want to apply, right, to our material. So PBR. All right, so that's kind of what we're going to be going into very soon. We're also going to be talking about UV mapping today, and I know that you guys know about UV mapping, but here is a bit of a review. So remember what we do when we do any kind of UV mapping. We take a flat image as an example. We have some kind of UV map, which is like we're going to sample for this image and we're going to wrap the image around an object. For example, in this case, sphere, right? And it's kind of a one-to-one mapping. We use different coordinate names. Instead of X and Y, we use something called U's and V's, so we don't get confused with what X and Y we're talking about. X and Y we use for positioning. U and V we use for positioning on a texture map. That's what we're doing. That's the difference between U and V and X and Y. U is the X on the texture map, and Y is V is the Y. And that's what when we talk about UV mapping, we kind of sample from a place in the texture map and we apply it one-to-one on the mesh, depending on which islands our map is kind of associated with. And we'll talk about that when we come to Blender. So example, I have a box, and when I unwrap the box, think about me having a 3D box and I unwrap it, or in this case, I have something that is spherical, and I want to unwrap some kind of sphere, and I want to put it around, or this is a flat mesh or flat texture map, and I want to take this and apply it to a sphere. Then each of the faces of the sphere are going to be applied to the texture. And notice this particular texture here, right? The little squares, the little checkerboard is a good indicator. If you see them stretched, as an example, sometimes we use the checkerboard as a test, because if you see it stretched, that means that you're going to have skewing of your texture in those areas. So you don't, that's why we don't want to have triangles too much in something like of an organic, some kind of organic object, right? Here, this might be more of a hard surface model, and so it doesn't really matter as much because mostly the surface might be, continuous, all right? But that's really what we're going to be talking about during our Blender out. So we're going to be talking about UV mapping, and our exercise today for lab 2, which is a bonus lab, all right, and you're going to take several screenshots. If you see what I wrote up in on Blackboard, let's go back to Blackboard for a second. On Blackboard, there is a, let's go back to course documents, and under week 4, which we're sitting at right now, we have a couple things to submit. One of them is our weekly PowerPoints, which is this document I'm showing you right here. Week 4, which is your weekly report, that's due tonight at midnight. Your first peer review is due Sunday, like we talked about, at midnight. And then your lab 2, which is a bonus, that's going to be due on Friday at midnight. So there's a lot of stuff you can do. If you follow along with the lab with me, then you should be able to get it done. I've given you a starter, and there's a series of textures that I've downloaded for you that we're going to use for the stone wall that you don't have to do on your own. All right, so that's the textures. And then, of course, I have this little video that I just did. I'm going to add my video, this new video that I'm doing right now. All right, so that's really what we're doing today, and that's really what I wanted to cover with this video and a little bit of talk. And I wanted to organize. Remember, our lectures are there for us to organize, kind of from an admin perspective, where we are with the project and how you're doing. And I always like to hear about, how the project is going. And that's why I asked for a couple of people to come up and talk about their project. This week, Russ came up and talked about how he procedurally generated the world. I'm really excited to see you guys, all of you, and your projects. As an example, as you're going to show, we're going to see your first release coming up on Sunday. And remember that there is a first release document. Please follow the document details, because that is how you're going to be marked, right? So again, if we look at the details for assignment number for project part 4, which is your first playable release, and again, that is embedded in your first playables release Dropbox up on Blackboard. But let's quickly take a look at it to see what I'm talking about, because maybe you haven't looked at it. Maybe you've been working towards doing stuff. So this is part 5 I talked about today. But remember that there is a part 4 that's due on Sunday, this Sunday at midnight. Please make sure you go through the document. And I went through this already. And it talks about what I'm looking for, where the marks are coming from. 40 marks for common requirements, right? 30 marks for game type requirements, right? As well as other marks for things like your GDD, which is worth marks, guys. Please do not forget to update your GDD, your release demo video, which is worth 10. and those kind of things. Your version control, which is worth 5. Your project management, which is worth 5. So there's something for everybody here in your team. All right, that's why this is not a one-man or one-woman show. So it's something that we're doing together as a team, and this is where you're getting all your marks. All right, so enough of that. So any questions before we stop the lecture for the day? I'm going to stop this part, and then I'm going to give us about 10 minutes, and we're going to start into our lab, which I'm going to record. All right. Thank you so much. Then if there's no questions about the stuff that I've talked about today, then let's take we're sitting about 2:46. We'll start our lab at 3 o'clock. I'll stay back and I'll answer any questions you guys might have that you want to talk about offline. Otherwise, for those people who are here for the lecture and who've done the lab already from this morning, thank you so much. I'll see you guys next week. I'm looking really forward to seeing your first playable release. That's due Sunday. For the rest, I'll see you guys in about 15 minutes. Okay, I'm going to stop sharing now.